In section 14.2, we're going to learn about one-sided limits, and so our objective is basically just to find one-sided limits. So I'm going to ask you to consider this function here, f of x, and the graph is shown for us there in green. As x is approaching 4 from the right side, f of x is approaching what y value? Okay, so if we're talking about approaching from the right side, so we've got here, you will notice this is where x is 4, all along this vertical line. So if we're approaching it from the right, we notice that y is then going to be approaching 2. Okay. All right, now we're gonna look at the same graph, and this time we're gonna consider what's happening as x is approaching 4 from the left side. So again, here is where x is 4, all along this line, and as we're approaching it from this side, from the left side, what is y approaching? And it appears to be approaching -1 in this case. Now, let's go back for a minute. When we are approaching from the right side, then this is actually written as the limit of f of x as x approaches 4 from the right side. So that's what we're going to call our right-hand limit. Okay, and this little plus that you see here means that we want it from the right side. Okay, and then let's go forward here on this one, and this time this is going to be written as the limit of f of x as x is approaching 4 from the left side. Okay, and again the negative is going to tell us that we are looking at it from the left side, and that's going to be called our left-hand limit. So you notice the limit from the left and right are they're different. So what we've learned in previous sections is that means that the limit does not exist. Okay, so the limit, so basically what that means is that the limit of f of x as x approaches 4 does not exist. However, the limit of f of x as x approaches 4 from the right-hand limit does exist. It's 2, and the left-hand limit here does exist. It's -1. They just so happen to be different, meaning that this does not exist. Okay, here we have an example we're going to work through, and you can do this using your calculator, or so let me pull up my calculator for a minute. So you can do this using your calculator, or you can also use those properties that we've talked about so far. So let's go through and use our properties, and then we'll also use our calculator in a minute. So with the properties, we could rewrite this as the square root. Let me wait on my calculator for a second. Okay, there we go. So we could write this as the square root of the limit we've already got our square root. This is the properties of limits that's going to allow me to do this. Okay, so once I have it here, then I know that this 2 minus x is just a polynomial. So what that means is that I can actually plug in 2 there to find that that limit is just going to produce a 2. So I get the, I'm sorry, I would get a 0 there. I plug in a 2 here, giving me a 0 there. So the limit of 2 minus x, the function 2 minus x as x approaches 2 from the negative side, I just plug in 2, and that gives me a 0, giving me the square root of 0 plus, and we have the limit of a constant, -3, and so we know that's just going to produce a -3. So we've got the square root of 0 minus 3 is going to give me -3. So it looks like in this case that the limit is going to be -3. So let's try it using a calculator and see if the calculator gives us the same thing. And let's clear that out. and I've got square root 2 minus x, and then minus 3, and I'm going to do zoom 6. Okay. Oh, we've got more than one graph going on here. Let me turn that off. Okay, that's off, and let's go back to our graph here. Okay, so here we see our graph, and you notice that our domain, and we should know this, so let's go back over here a little bit. We should know, since you have the square root, you know that your domain of this, what's inside your radicand, 2 minus x, has to be greater than or equal to 0, telling us that x has to be less than or equal to 2. So this is our domain here, and so when you go back to your graph that we're looking at, you see that you see that domain of x is less than or equal to 2, because it starts at -2 and then moves to the left there. So let's take a little bit off of this graph. Let's go x max, since the domain is, we can just change that to 5. Let's make that -5, and we'll make this +5, and look at the graph now, and you get a little better graph there. Okay, so we're going to be approaching it, you notice here, from the left side. We're looking for the left-hand limit, and that makes sense considering the restrictions on our domain here, and then also by looking at the graph. We could not approach it from the right side because the function is not defined there at that point, at those points. So if we go to our, let's see, make sure we're in ask mode. We are. So I'm going to go to my table, and I'm going to plug in some values, and I'm going to approach 2. So I'm going to start with 1.9. Okay. And then I'm going to 1.99, 1.999. Okay, and then I'll go ahead and enter 2. Okay, so it does look like here that we're also approaching -3. So in this case, the limit of this function as x approaches 2, the left-hand limit, is going to be -3. All right. So when we are computing left-handed, or when we're computing one-sided limits, all the results about limits from the previous section, properties of limits, those are still going to hold true. And you saw that we just used those properties in the example that I worked through. Limits of polynomial functions and the limit theorem are also valid when x approaches c is replaced by x is approaching c from the left or from the right. So using your left-hand limits and your right-hand limits. So you can still use all of those properties, the limit function, I'm sorry, the limit theorem, and to help you evaluate those. Okay, here's another example, and this is going to be our final example. I'm sorry, it's not. We're going to work through one more example after this. So we, again, could use the calculator, or we can use our limit theorem, so our limit properties. So I could change this. No, this is, we have a quadratic in the radicand. So you know that 16 minus x squared is going to be greater than or equal to 0. So this is one of those that you actually have to do the test values on to see. But if you graph it, you can also pretty easily see what the domain is there. So we are approaching 4 from the right-hand side. So it might help us, let's actually use a calculator this time to graph it, and you can probably then see what the domain is going to be for you. So this time we're going to have 16 minus x squared. Okay. Change my window. I'm going to change this to -5. Graph that. Okay, so you see that your domain happens to be between, it appears to be between -4 and +4 here in this case. Now we want to know what happens as x is approaching So we have something that looks, we know that our graph looks something like this. And we want to know what's happening as x is approaching 4. Actually, this right here is wrong. This should be 4 from the, this should be like that. Okay, we want to approach 4, the left-hand limit. Okay, so there's where x equals 4, and we want to approach it from the left-hand side. Okay, so that's what we're looking at. So we're going to get really, really close to 4, meaning that we're going to start with let's see, meaning that we are going to start with 3.9, 3.99, 3.999, and see what kind of values we get for those. So, all right, let's go over here and okay, so we're going to enter 3.9, 3.99, and 3.999, and then we'll go ahead and enter 4. Okay, so you notice when you enter 4, you get 0, and I had an error here. Hit 2 3s. It should be 3.99. Okay, so it appears that we're approaching 0 in this case. And now if we go back and we actually use the properties, then we could go through and say, okay, this is a square root. Change this to the limit. And 16 minus x squared without the square root is just a polynomial, so we can just plug in the 4 there. And when we plug in the 4, we get 16 minus, and that's going to be the square root of 0, which is going to give me 0. So in both cases, I find that the limit of this function as x is approaching 4 from the left side is going to be 0. So in conclusion, the way you use this, okay, you've got 3 types of limits. You've got your left-hand limit, you've got your right-hand limit, and you've got your two-sided limit. If your left-handed and right-handed limit are the same, that is these two, then this will exist. Okay, your two-sided. So this and this both are equal to the same number. Those both equal to L, then your two-sided limit will exist. If one is equal to L, the other is equal to M, so that's a case sort of like this here you have going on, then the two-sided limit will not exist. And one last example here. This time we're going to use this graph and we're going to find the different limits. So the first one, I am talking about x approaching 5 from the left-hand side. So here is where x is 5. Okay, and I want to approach it from the left-hand side. So if I'm approaching from the left-hand side, then my limit there is going to be at 4. Okay, now if I want to approach that same number but from the right-hand side, I still get 4. So what that means is that since if I approach it from the left-hand side and from the right-hand side, they're both the same, that means that this is equal to 4. Okay, now let's look at 3. So if I have x is 3, is along here. If I approach it from the left, then I end up with 3. If I approach it from the right, I end up with 5. So in this case, we know that the limit of this function, f of x, as x approaches 3 would not exist. And that's all I have for section 14.2a.